Hello, hi everyone. Welcome to Vedantu JEE English, and I'm Diksha Kaushal, your chemistry master teacher. So everybody, do let me know if I am clearly visible and audible to you so that we can start with the session. And in today's session, guys, we are going to do GOC, right? This is day 3 of 5 days challenge. Till now, we have completed chemical bonding, we have done coordination chemistry that we did in yesterday's class, and today we are going to do GOC. Now, in GOC, we are going to talk about from where the most of the questions are asked is stability of intermediates, acidity and basicity. For that, we need to understand these effects like plus I, minus I, resonance, hyperconjugation, all of these we'll talk about in today's class. Yes, everybody, do let me know if you all are ready for the class so that we can start with the session. Yes, everybody, do let me know everyone in the chat box so that we can start with the session. Yes, students? Okay, so let's start with the session without wasting any time. Now, first thing, all the reactions, ma'am. In GOC you don't have reactions. GOC is about electron displacement effects. It's about you talk about stability of intermediates, stability of carbanion, carbocation, how we define acidity based on these effects, how we define basicity based on these effects. That we are going to talk about in today's class. Okay, everybody? Shall we start the session? Yes, everybody? I hope so. Now it is clear in your head, right? So, starting with inductive effect, first electron displacement effect is inductive effect, right? And in inductive effect, we actually talk about electronegativity, right? That inductive effect is based on the electronegativity. There are two kind of inductive effect. One is plus I, then there is minus I effect. In case of plus I effect, what you have, in case of plus I effect, you have donation. That means electrons are being donated, they are supplied, right? In minus I effect, electrons are being taken out. And here, actually, it's not like you will have a particular bond and from there you are taking out the electron. It's more like you have A and B and they will have electronegativity difference. Let's say this is minus, this is plus. Now the shared pair of electron will be towards this A and that will have minus I effect. The shared pair of electron will be towards B. That will be called as, it is towards A, that is why B is having plus I effect. It is giving the electrons to A. So electrons are not actually delocalized in this case, electrons are displaced in this case. In the same sigma bonds, electron will change its position, that is called as inductive effect. Again, I am saying electrons are not moving in some other bond. Electrons are not delocalized, electrons are displaced. Like I am standing here, if someone pushes me here, I will stand here. That is inductive effect, right? So now let's talk about the effects that shows plus I and minus I effect. If you talk about plus I effect means electron donation. So this is the order. All the negative charges will have more electron donation. Here CH2, then you have NH2, then you have O. Why firstly C negative, then N, then O negative? Reason being, because here electronegativity of oxygen is very high, so its donation will be less, right? So firstly CH2, then NH2, then you have O negative. In this case, if you see in these two cases, here you have O negative and here you have COO negative. In this case, electron is also delocalized and that is why it has less donation as compared to simple O negative. Then we have 3 degree, 2 degree and 1 degree. In case of 3 degree, you have these three effects. These three alkyl groups are actually showing plus I. They donate the electrons, right? So you have 3 alkyl group, that means very high plus I effect is there. Here you have 2 alkyl groups, here you have only one alkyl group, and whenever here this is 3 degree, this is 2 degree and this is 1 degree, when you compare to 1 degree, more the number of carbons, more will be the plus I effect, right? Now next is when you compare tritium, deuterium and hydrogen. In that case, tritium has maximum plus I effect, then deuterium, then you have hydrogen which has less plus I effect as compared to these two other isotopes of hydrogen. Then guys, we have minus I effect. In this case, there is a little correction here. This is Nr and this is going to be NH, okay? This is Nr and this is going to be NH. Let me just correct that. This is Nr3, this is NH3, okay? So when you talk about the minus I series, that you should remember as it is, because questions are asked. Last one is methyl, ma'am. Wait a minute. Yes, this is methyl. Wait a minute. Yes, you are correct. Wait a minute. Let me just write it. CH3. You are right. That is CH3. Okay. Now let's talk about minus I effect. If you talk about minus I effect, you should remember the series as it is, right? First you have NF3, NR3, NH3, then NO2SO3H, CN, CHO, COH, then halogens, then OC6H5, then you have ester, then you have OR. Now OR has one thing to remember, OR is less minus I as compared to OH, right? And when you talk about SR and SH, SH has more as compared to SR. These two are also important things which they can ask you as it is, and this one can be quite confusing for the students, right, if they have not learned the theory, right? Okay, yes everybody, yes, okay. Today now you just have to see this lecture, right? Firstly, your GOC has to be very good. If you want to solve organic chemistry problems, GOC you should have a very good hold on, right? Now let's see, based on that, there is one thing that that the question can be asked, assertion reasoning kind of question can be asked here. So we are saying that NR3 has more minus I effect as compared to NH3. Ma'am, why so? What is the reason behind that? Let's talk about that. If you talk about NR3, right? NR3 has big. Now, what is the problem, ma'am? Why it is questionable? It is questionable because this has plus I effects. So, because of more plus I effect, right? More plus I effect, it should have less minus I effect. So, minus I order should be like this. Because it has 3 alkyl group, it does not have alkyl group. This will show more plus I effect. More plus I means less minus I. So this should have less minus I. That means the order should be NH3 positive greater than NR3 positive. This should be the order, right? But in reality, this is not the order. Ma'am, what is the reason why so this is not the order? So for that, see this thing, you have 3 alkyl groups, right? And these 3 alkyl groups are very heavy, right? They have steric hindrance. And because of that, if you see a tetrahedral species, if here you have a positive, then if you have a big alkyl groups here, they will cause repulsion in this case. Because of the repulsion, this bond angle, if these atoms are small, then bond angle will stay 109 degree only. That is there in case of tetrahedral. But if you increase, if here repulsions are very high, the bond angle is going to increase. That means because of the steric hindrance, we will say the bond angle is going to increase, right? Now we have studied this in chemical bonding, that bond angle is directly proportional to electronegativity. Bond angle is directly proportional to electronegativity, right? More the, wait a minute guys. So bond angle is directly proportional to electronegativity. If here bond angle is very high, then electronegativity will be quite high, right? Then we can say that electronegativity will be quite high. If the electronegativity is high in this case, that means minus I effect is going to be high in this case. Why I have told you about this thing? Because from here assertion reasoning question can be asked. Right everybody? Is that clear to everyone of you or not? Then guys, we have some examples where we are going to talk about plus I effect of different cases. Now if I say you have tritium, deuterium and hydrogen. Now here we can say which has more plus I effect. Tritium has maximum, so that is why this will CT3 will have maximum, then CD3, then you will have CH3, right? Then guys, we talk about if you have same kind of thing here you have CH3, CH2D, CHD2, CD3. So deuterium has more plus I effect, that's why the answer is going to be CD3, CHD2, CH2D and CH3, right? Then we have this question where again they are asking you minus I effect, which has electron withdrawing power, the maximum electron withdrawing power here. So for that, what we will do? For maximum electron withdrawing power, the simple thing that we will do here is, this is C double bond O H, right? Now in this case, see this thing very carefully. You have C double bond O. This is oxygen here. This is nitrogen here. This is carbon here. That is the only difference that you have. Otherwise, all of them are sp2. This has maximum electronegativity. That is the reason the order is going to be, this one is the correct order for the minus I effect. Then guys, when we talk about down the group, what will happen? Down the group always, because the size is increasing, as size increases, electronegativity decreases. That is the reason down the group, the minus I effect is going to decrease here. Hence, the order is going to be this one for any group that you have. Okay, everybody? Why the students are so less? Huh? Why the students are so less today? Wait a minute. Let me just see. Okay, let's see. Ma'am, I am here. Chalo. Now the next thing that we are going to do is resonance. Okay, next thing, because in the end I am going to combine all these effects and see the stability of intermediates. For that, firstly I will have to go through all the effects here. Second effect is resonance effect. Now in case of resonance, you have delocalization of electron. That means electron will be delocalized to some other position. It will move to some other position. Displacement is not only the factor here. Delocalization means the electrons will jump from here and there. It will shift from here and there, right? Now resonance is actually, as I am telling you, this is delocalization of pi electrons. Pi electrons will be delocalized in this case. So first is double bond and p orbital, then alternate double bond, single bond, third is back bonding. So let's talk about all of them one by one. If you talk about double bond, single bond and p orbital, the first case is double bond, single bond, p orbital. Now that p orbital can be lone pair, that p orbital can be negative charge, that p orbital can be a carbocation, and that p orbital can be a free radical. Okay. Now if you see, whenever you have double bond, single bond, this is very important thing that you are going to use throughout organic chemistry. If you have double bond, single bond, lone pair, then lone pair will shift to bond pair and bond pair will be shifted to negative charge, and hence this will be the resonating structure that you will have, right? If you have double bond, single bond, negative, in that case this negative will shift here and double bond will be converted to negative charge, and hence you will have again double bond, single bond, negative in the opposite direction, right? Then if you have double bond, single bond, carbocation, then these pi electrons will form a double bond on the next position, and here you will have a carbocation, and hence this will be carbocation, single bond, double bond, right? Next is if you have double bond, single bond and free radical, then in this case you will have homolytic cleavage. Now ma'am, what do you mean by homolytic cleavage? Let's talk about that. Let's talk about, ma'am, what do you mean by homolytic cleavage? Here electron will shift here, here electron will shift here. So here already you have a free radical and one more electron you have, so it will make a double bond. Here one electron has shifted here, that is called as free radical. So that's how you will form the resonating structures of double bond, single bond and p orbital. P orbital can be lone pair, negative charge, carbocation or free radical, anything can be there in that p orbital. Second category is when we talk about alternate double bond, single bond. So in case of alternate double bond, single bond, what you will do, double bond will be shifted to the next position, and this double bond will be shifted to the next position. So double bond is converted to double bond, right? And here you will, because the electrons are shifting, here you will have a carbocation, and here double bond is shifted to this place, that's why here you will have a negative charge. So overall you will see this is also neutral, this is also neutral. Overall charge in a resonating structures, in all the resonating structures has to be same, right? Overall charge should be same. Here positive and negative is neutral, this is overall neutral. Third category is back bonding, right? Third category is back bonding. So now guys, what do you mean by back bonding? In case of back bonding, always you should have one electron rich and other should be electron deficient. They should be connected next to each other, okay? Electron rich and electron deficient should be connected next to each other. So here what we will do, here lone pair will be shifted to bond pair and hence you will have a positive here. Here in this case also, because this boron is electron deficient, this is electron rich, this is electron deficient, so what will happen, this will shift here and hence you will have CH2 double bond BH2, and here you will have a negative charge because extra electrons you are giving here, right? Okay, according to that you will have your answer. Do let me know, ma'am. O positive is unstable, right? Yes, O positive is unstable. That we will talk about in instability of resonating structure. Till now I am just telling you resonating structures will exist in these cases. I am not talking about stability of resonating structures, right? Till now we are only discussing that resonating structures are going to exist in these particular things, right? Now let's talk about that two cases, that is cross conjugation and extended conjugation. So what do you mean by cross conjugation? Cross conjugation is when you have double bond, single bond, double bond, single bond, carbocation, double bond, single bond, carbocation. So resonance can happen from this side, resonance can happen from this side. Both the sides resonance is happening, that is cross conjugation. When it is this double bond can shift here, then this double bond can shift here. First resonance is double bond, single bond, double bond. When this will happen, this double bond is shifted here and this will become negative, then this bond will shift here. That is called as extended conjugation. One conjugation is here, second conjugation is here, but it is in the same direction. If the conjugation is in the opposite direction, that is cross conjugation. If it is in the same direction in continuous form, that is extended conjugation, and always extended conjugation is more stable as compared to cross conjugation, right? Okay. Next point is dancing resonance. Now, what do you mean by dancing resonance? Everybody, let's see that, right? In dancing resonance, you will have a cyclopropyl, right? And over here, you will have a cation. So, what will happen in this case? This particular bond here will shift here. This is a very, very important kind of resonance. If anywhere you see dancing resonance, that is going to make the structure most stable, right? So here what will happen? Here what will happen? You will have this bond as it is, this bond as it is, okay? And this is the double bond you will have, and this is the positive charge, right? Here one more thing can happen, that is this bond can shift here. In this case, what you will have this as it is, this as it is, and here you will have a double bond, right? And this is the positive charge, right? So this is what you have. This is called as dancing resonance. It's like when you're doing dance, you are never doing dance on one leg. You're always doing dance and you're never doing dance like with two legs on the floor, like this dance you don't do. You always do dance like you take out your leg up and down, up and down. Similarly here, that's why it is called as dancing resonance. Firstly, this leg is up, then this leg is up, and these things are dancing resonance. And dancing resonance has most stability. If anywhere you see dancing resonance, that is a very stable compound. Okay? Yes, everybody. Now let's talk about two type of resonances that you have, and it is also called as mesomeric effect. It is also called as mesomeric effect. Now, ma'am, what is the difference in resonance and mesomeric effect, right? Let's see, right? If existing means Lohaji, I didn't get you. What do you mean by if existing? Like, tell me the full statement. Okay, yes. See, because three-membered ring is not stable, that's why it is happening in three-membered ring. Okay. It will not occur everywhere, right? Okay, it will not occur everywhere, right? Okay, now let's see this one, resonance and mesomeric effect. Now let's talk about resonance. In case of, what is the difference in resonance and mesomeric? If you talk about this thing here, this and this, okay? Now, if you talk about benzene, double bond, single bond, double bond, single bond, double bond, right? I'll just show you here. If you talk about benzene, this is double bond, single bond, double bond, single bond, double bond. That is full conjugation there. If the conjugation is not because of any external group, that is called as resonance. But if, for example, I have a group that is OH here, and because of that the resonance is happening, that is called as mesomeric effect. Okay. So, mesomeric effect are of two types. It can be plus M, it can be minus M. Ma'am, what do you mean by plus M? Ma'am, what do you mean by plus M? Let's talk about what is, I'll give you a simple trick for that, right? You don't even have to remember the groups. If next to the benzene ring, you have a group here, next to the benzene ring, you have a group here, which has lone pair of electrons, right? Then it will always and always show plus effect, plus M effect, right? If next to the benzene ring you have a group, if next to the benzene ring you have a group that is connected to a atom which is more electronegative, B is more electronegative as compared to A, then it is going to show minus M effect. Let's see how. Plus M means electron donation because it has lone pair, so here it will donate the electrons into the ring. That's why it is plus M. That's why it is plus M, right? Minus M because this is more electronegative, it will take out these, and always A is connected to more electronegative element with a multiple bond. Only then we can say minus M effect is existing here. So electrons will move to this side. This particular bond will shift here. That is nothing but minus M effect, right? Okay. Now let's see, plus M effect is, for example, you have lone pair of electrons in case of phenol, so it will shift here, this will move here, it will show you plus M effect. In case of NO2, if you see, if you see, here you will have N double bond O, this is O, right, this one is positive and this one is negative. This is the structure of NO2. Nitrogen is less electronegative as compared to oxygen, and it is connected by a multiple bond. So this pi bond will shift here, this pi bond will shift here, and that's how it is going to show you minus M effect. Right, everybody? That's how it is going to show you minus I effect. Tell me about it if that thing is clear to all of you or not. How it is going to show you minus M effect. Right, everybody? Now there are so many examples of plus M and minus M based on the same thing. Here it has lone pair, that's why plus. Here it has lone pair, here it has lone pair, here it has lone pair, here this has lone pair. That's why all of these are the examples of plus, and these are not connected to multiple bond with the more electronegative. But in this case, carbon is connected to pi bond with more electronegative. Carbon is connected to pi bond with more electronegative oxygen, right? This is the same thing, why we have written it again, right? This is the same thing, why we have written it again, right? Then we have sulfur is less electronegative as compared to oxygen, connected by multiple bond. Carbon, oxygen, less electronegative, more electronegative, connected by multiple bonds. Same thing and same thing here, right? And that's why all these are the examples of minus M, or you can say minus R effect. Everybody, is that clear? Now let's see how the resonating structures work, right? So simple way is, we have lone pair here. This lone pair will shift here, this pi bond will shift here, you will have a, wait a minute, this lone pair, wait a minute, how I draw, this lone pair will shift here, acha, no, wait a minute, how does the resonance works? Let me just erase the arrows here, okay? Arrows can be a little confusing here, right? So it will show you plus M. Let's see how it is going to show you plus M, and what is the effect of plus M and minus M on the reactions, that what kind of product will be formed, how it will be defined by plus M or minus M, right? Okay. Yes, everybody? Vishal, yes, I don't know, Vishal. I have no idea about what the big thing you are asking me. I'm so sorry, Vishal. I don't know. Okay, Vishal, you can go. Right? Now, let's see, guys. Here, you have lone pair, single bond, double bond. And what I told you, whenever you have lone pair, single bond, double bond, always lone pair is converted to double bond, and double bond is converted to negative charge. That's why here you have negative charge, and because from here you are shifting the lone pair, so oxygen, whenever oxygen has 3 bonds, it always has a positive charge. Okay, whenever oxygen has 2 bonds, it has a negative charge. Right? Now again you have negative single bond, double bond. Negative is shifted to double bond is shifted to negative charge. Right? So this will be double bond, negative, and this. Double bond, single bond, negative. Now this negative is again shifted to double bond is shifted to negative here. Then you have negative single bond, double bond. This negative is shifted to double bond, and this double bond is shifted to negative here. Negative positive will become neutral. So here you will have this as the answer. Now can you see that we can directly see that on the ortho and para. Now this is ortho, this is meta position. Oh my Prabhu, para. This is meta, this is ortho. Now we can see that on the ortho positions, if you see over here it is ortho, over here it is para, over here it is ortho position. Now we can see in the plus M effects on the ortho and para position, ortho and para positions, you have negative charge. And that is the reason whenever an electrophile is attacking on these groups, which shows plus M effect, they will always form a product which is ortho-para directing. Okay, understood? Now, let's talk about, these are ortho-para directing, ma'am. Then what about the one having minus M effect? Now, this one is showing minus M effect. This one is showing plus M effect, right? Okay, this one is showing plus M effect. Wait a minute. Is it like more resonance than more? Yes, it is like that. Beta, have patience, please. Have patience, right? Don't ruin this lecture for me, right? Okay? Don't ruin this lecture for me. You have already ruined it. So, like, already my mood is off because of I can see the chats over here, right? But don't ruin it more for me, right? Have patience and see what I am doing, right? Okay? Okay, I am not talking about stabilization right now, right? I am not talking about stabilization. Let's see this, right? Ortho and para position, you have negative charge. That is why they are ortho and para directing, that is plus M. Talking about minus M, what you will see that here, firstly the electron, this particular bond will shift here, this bond will shift here. That's why on the ortho position you will have positive. Then this bond will shift here, on the para position you will have positive. Then when you will have positive, this bond will shift here, then here you will have positive, right? That means, can I say that on the ortho and para positions, you have positive charge here. So whenever you have positive charge on the ortho and para position, that means whenever you have an electrophile that is attacking here, whenever an electron loving species is attacking here, it will attack on the meta position because meta has more electron density. Meta has more electron density, right? Because ortho and para is now positive. So on the meta positions, there is no positive charge. That means there is more electron density. So electrophilic substitution reactions will always occur on the meta position in case of minus M effects, right? Okay, everybody? Yes, everyone? Now, let's talk about deactivating and activating nature of plus M and minus M effect. If you talk about plus M, as you can see, they are providing the electrons, so they are activating in nature. They are activating the benzene ring because they are giving the electrons. They are taking out the electrons, that is why they are called as deactivating. So, always you should remember that, wait a minute, this I'll just put here. This is an exception of this effect here. Now, always remember that plus M effect is always going to be ortho-para directing, and this is going to be activating, right? And minus M is going to be meta directing, and this is going to be deactivating. But this also has an exception. There is an exception for this. Let's talk about the exception here. The exception here is halogens. In case of halogens, it shows minus I effect. In case of halogens, it shows minus I effect. See, in case of phenol also it was showing minus I and plus M. If you talk about this situation, in this case also because of oxygen it was showing minus I and plus M. But mesomeric effect is always more dominating. In this case also it was showing minus I and minus M. Mesomeric is more dominating, right? That's why here this is because dominating effect is minus, that is plus, that is why it is activating. Here dominating effect is minus, that's why it is deactivating. So the activating and deactivating does not depend upon plus M or minus M. That depends also on the factor whether mesomeric is dominating or not. In case of halogens, you have minus I and plus M. Plus M because halogens, they have lone pair of electrons, right? That's why it is plus M. Minus because they are very electronegative. Now in the case of halogens, exception is that inductive effect is more dominating, not mesomeric effect. Now different thing is that inductive effect here is more dominating. Whenever you have inductive effect as more dominating, now because of plus M effect, it will be orthopara directing only. It will be orthopara directing only. But because of dominance of minus effect here, it is going to be deactivating in nature. That's why this is very frequently asked that halogens, they are in the exceptional case. Right, everybody? Okay. Yes, students. Do let me know if that is clear to all of you or not, so that we can start with some questions here based on this one. In JEE 2023, a question has been asked. They are asking you which will undergo deprotonation readily, right? That means from this carbon, you should have deprotonation. Here, you should have one carbocation, one carbocation, one carbon. If you lose one hydrogen, then there will be the formation of a carbocation in this case. Now, here you will see that double bond, single bond, carbocation. So what will happen? This will be stabilized by, and this will also be stabilized by two resonances here. Here also same thing will happen. Here also same thing will happen. But also one thing, that these lone pairs that you have here, right? Now always remember one thing about carbocation, that in case of whenever we are talking about a carbocation that is positive, right? If you donate the electrons, right, electron donating group, that will become very stable. If you take out the electron, that will become unstable. If you have electron withdrawing group, it will become unstable, right? Now here actually it is not directly related to this thing. Wait a minute. It is not directly related to this thing. Here we want resonance from this double bond, these pi bonds, we want resonance from here, right? But what is the difference that we can see? That here you have one lone pair. So this particular double bond is also involved in this resonance. Double bond, single bond, lone pair. So what will happen? These lone pairs will shift here. This double bond will shift here. Here resonance will occur from two sides, here and here as well. Here resonance will not occur. Now what do you mean by that? To make the carbocation more, deprotonation can only happen if the carbocation formed is more stable. For that carbocation to be more stable, you should have electron donating group, only then it will be more stable. For that to be more stable, what you should have, if you want the carbocation to be more stable, you should give the electrons. Electrons can only be given by these carbonyl groups that you have here. Electrons can only be given by these carbonyl groups that you have here. Now carbonyls group you have here, that's why electrons should be given here. But because of this particular situation here, in two cases, these pi bonds are not available for the donation. Here these pi bonds are available, but these pi bonds are not available. So pi bonds are available maximum in these two cases, where these pi bonds are totally involved in donation here. That is why this will be maximum stable. So answer will be A is the correct answer here, right? Yes, definitely I can see your messages, guys. Okay, understood? That's why A is the correct answer. Do let me know if that is clear to all of you or not. Right, everyone? So A is going to be the correct answer, right? Okay. Next is identify correct statements. Now they are asking you based on meta directing in this effect only. JEE Mains 2025 question, that is asked on simple thing plus M and minus M effect. So here they are saying OCH3 and this are activating groups. Yes, because they show plus M effect. They are activating, that's true, right? CN and OH are meta directing. No, OH will be ortho para directing. This will be meta directing. That is correct because CN is C triple bond N. This will show minus M. That is why it is going to be meta directing. So this is the incorrect statement. This is false. CN and SO3H are meta directing. That is true. SO3H is also having this kind of bond, S double bond O, OH, this kind of bond is there. So it has more electronegative element connected by pi bond. So both of them are going to show you minus M effect only. So that is true here, right? They are asking for correct statement. So first is correct here, C is correct here. Till now A is correct, C is correct. Then activating groups act as ortho para directing. That's true. Activating groups, halogen is the exception. You will say, ma'am, but halogen is deactivating. It is acting as ortho. Halogen is the exceptional case. Otherwise, in general, activating groups act as ortho para directing. That is also true, right? So D is also true here. Halides are activating. No, halides are deactivating groups because minus I is greater than plus M. So it is deactivating group. So this is going to be false. So answer is A, C, D are the correct statements here. So write A, C, D, that is A is the correct answer here. So A is the correct answer here. Okay, everybody, understood? Is that clear? Is that getting clear? This was your latest question. Now, one question that Lohajit was asking, ma'am, what about stability based on resonating structures? Now guys, always remember, if there is a structure where you have no resonance and if there is a structure where you have resonance, then definitely the one with the resonating structure is always going to be more stable. And more the number of, if I am talking about two different compounds, then the one with resonating structure is going to be more stable. More the number of resonating structures, more will be the stability. And if you have equivalent resonating structure, then also it is going to be amazing resonance, and that is why it is going to be stable, right? So resonance is going to give you stability, that is true, right? This is for different compounds, right? Yes, Tarun, we will do thermodynamics. Don't worry about that. We will do that, right? Okay. Now just focus here, right? Now if you see, resonance is going to give you stability for different compounds. But what if, ma'am, I want to talk about the stability of same compound resonating structure? You have three resonating structure of same compound. How do you give which one is most stable? For that, you have to follow these steps here. The steps are, neutral is more stable as always. This is how you have to follow. This is first, this is second, this is third, and this is fourth, right? Neutral is more stable as compared to charged. Neutral resonating structure is going to be more stable as compared to the charged resonating structure. If all the structures are neutral or all the structures are charged, then you will see that stability depends upon number of pi bonds. More the number of pi bonds, more is going to be the stability here, right? If let's say, ma'am, number of pi bonds are also same, then you will see that negative charge is more stable down the group and along the period, right? You will see where negative charge is more stable, it is always stable, more stable down the group, and along the period. It is always more stable, right? Okay. Then more charge separation. If negative charge is also on the same species, then you will see more the charge separation, less the stability. For example, here you have one is O negative, one is S negative. The one with S negative is going to be more stable because down the group negative charge stability will increase. If you have something that is having O negative and something which is have F negative, so F negative is going to be more stable because negative charge stability increases along the period as well. Now, if you have charge separation means if you have two species where positive negative is here and then its resonating structure you have where you have positive negative like this. Which one is more stable? Here charge separation is more, here charge separation is less. Less charge separation means more stability. So this is going to be more stable as compared to this because stability is inversely proportional to the charge separation. Here less charge separation means more stability. Is that clear? Okay, everybody. Let's do questions now. Ma'am, from here also the questions are asked. Yes. JEE 2024 question that they have asked you here. The correct stability order of following resonating structures are which? They are asking you the correct stability order, right? So in this case, you have this first structure, this is the second structure, this is the third structure. First, I'll see if any structure is neutral. I can see this particular structure here is neutral, so third will have maximum stability. Then these two are charged. I'll see number of pi bonds then. This has one pi bond, this also has one pi bond. So by number of pi bonds, I cannot differentiate this. Now I will see negative charge. Here negative charge is on carbon. Here negative charge is on oxygen. Oxygen, carbon, this is carbon, nitrogen, oxygen. So along the period negative charge stability increases. So this will be more stable, so it is going to be second and then it is going to be 1. So answer is going to be 3, 2, 1 is the correct answer here. That is C is the correct answer here. This question, very good, very good, very good. This question was based on the stability of resonating structures. Okay. I minus is unstable. Which I minus, beta? Which I minus? Which I minus? I minus, I never talked. This is not iodine. This is minus I effect. Minus I effect in case of halogen is more dominating as compared to plus M. That's why halogen is deactivating in case of minus I. It is orthoparadirecting because of plus M. Right? That is an exceptional case. Right? Now guys, let's talk about hyperconjugation. Right? Very simple effect this is, hyperconjugation effect, very simple. I'll tell you the conclusion part of it. First thing is, what is the condition of hyperconjugation? What all can show hyperconjugation? Alpha carbon should be sp3. First thing is alpha carbon should be sp3. Then at least one alpha hydrogen should be there, right? Number of alpha hydrogen will define the stability of that intermediate, right? More the number of alpha hydrogen, more will be the hyperconjugating structure, more will be the stability. If you see this, this is shown by alkene. Majorly you will see this in alkene, carbocation and free radical. And free radical. Okay, let's talk about that. Here you have alkene, okay, two alkenes, you have one free radical. I'll talk about this carbocation. Carbocation, this is carbocation, then this carbon will become alpha, this will become alpha. This is sp2, this is sp2. That is the reason no hyperconjugation will be shown by this particular structure, because this condition is not valid here. That's why no hyperconjugating structures. Over here, this is the alkene, this is alpha, this is alpha. Here alpha has, when you complete the valency, 2 hydrogen, that means 4 hyperconjugating structures you have here. In this case, what you have, in this case, this is alpha, this is alpha, this is alpha, this is alpha. Here you have 3 hydrogens, here you have 3 hydrogen to complete the tetravalency, 2 hydrogens and 2 hydrogens, 3, 3, 6, 7, 8, 9, 10. 10 hyperconjugating structures. So we can say this one is more stable as compared to this one because of the more number of hyperconjugating structure. And Sedgwick rule that you will study in reaction part, that is based on hyperconjugation only, right? Okay. Let's talk about this question for your practice. I am doing this. Tell me, which one is more stable? This is alkene, this is alkene, and this is alkene. Calculate alpha. Next to alkene is alpha, next to alkene is alpha. Alpha, alpha, and this is also alpha. Here this is alpha, and this is alpha. What about hydrogens here? Here you have 2 hydrogens. Here you have only 1 hydrogen. Here you have 2 hydrogens, right? Here you have 3 hydrogens, right? Here you have 2 hydrogens, okay? Here how many hydrogen you have? 1 extra hydrogen you need to complete the tetravalency. How I am attaching the hydrogen to complete the tetravalency of carbon? 2 bond already there, so I need 2 hydrogens. So let's calculate the number of hydrogen. 1, 2, 3, 4, 5. 5 hydrogen, 5 alpha hydrogens. This is 1, 2, 3, 4, 5, 6, 7. 7 alpha hydrogen. This is 1, 2, 3. 3 alpha hydrogen. So answer will be B, then C, then A is going to be the correct order of hyperconjugating structures here, right? Okay. Okay. Acha, you are asking about Cl negative and I negative charge. Which negative charge is more stable? Down the group it is, down the group and along the period it increases. So I negative will be more stable as compared to Cl negative. Okay. I negative is going to, because down the group it increases. Here we have told you that down the group it will increase. Negative charge more stable down the group, right? Okay. Acha, now let's talk about last thing here, that is aromaticity, and after that I'll combine all these effects and we'll do a lot of questions of stability of intermediates. Let's do that. Okay everyone, let's do that. Ready everyone? Aromaticity. From aromaticity directly also the questions are asked. Okay, directly also the questions are asked from aromaticity. Let's talk about that. In case of aromaticity, first you will have to check planarity, cyclic and complete conjugation, that is PCC. Okay, so firstly I will see planarity, cyclic and complete conjugation. If this is valid, PCC is there, it is planar. Planarity means it should always have sp2 hybridization in all the cases. sp2 means trigonal planar. So planarity means it should be sp2 hybridized, right? Then cyclic means it should be a cycle. Complete conjugation means from resonance you can say how complete conjugation should be there throughout the ring. There should not be a break in the conjugation. If it is PCC is valid, all the conditions are valid, then you will check the number of pi electrons. If number of pi electrons falls into the category that let's say you have 2 pi electrons, if you put n is equals to 0, this will become 2. If you have 6 pi electrons, if you put n is equals to 1, this will become 6. If you have, let's say, 4 pi electron, if you put n is equals to 1, this will become 4. If you have 8 pi electrons, if you put n is equals to 2, this will become 8. If you have 16, if you put n is equals to 4, this will become 16. So now that will depend upon how many number of pi electrons you have. If you have 4n plus 2 pi, that is aromatic. If you have 4n pi, that is anti-aromatic. If any of the condition is not obeyed, maybe it is not planar, maybe it is not cyclic, maybe it is not complete conjugation, that is going to be non-aromatic, right? And always remember, aromatic maximum stability, then you have non-aromatic, then you will have anti-aromatic, that is least stable. Anti-aromatic, that is least stable in this case. Okay, anti-aromatic is going to have the least stability, less stable it is going to be, right? Okay. See, these are some of the compounds that you have to tell me about the aromatic, anti-aromatic character, right? This will help you, right, to understand things in a better way, right? Let's do that. If you have planarity, firstly I'll see carbocation under delocalization or carbanion under delocalization always will be sp2. Okay, this is sp2, 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 double bond, single bond, positive, single bond, double bond, complete conjugation, it is cyclic, PCC is followed, 2 pi electrons it has, so it will be aromatic in nature. In this case, again PCC is followed, planarity is there, cyclic, it is complete conjugation. So 1, 2, 3, 4. All the electrons that are involved in delocalization are pi electron. So this is involved in delocalization. So it will be 4 pi electrons, that is anti-aromatic in nature. Okay. Next is this one, 1, 2, 3, 4, 5, 6. Now here it is cyclic. Double bond, single bond, double bond, single bond, positive, single bond, double bond, single bond, double bond, complete conjugation. Yes, it is planar. This is sp2 and all the double bonds will be sp2. So PCC is followed, 1, 2, 3, 4, 6 pi electrons. That means it is aromatic. It falls into the category of 4n plus 2 pi, right? Then here you have 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. This is falling into the category of 4n pi electrons. This one is having 1, 2, 3, 4 pi electrons. Again, this is anti-aromatic in nature. This one is 1, 2, 3, 4, 5, 6 pi electrons. This is going to be aromatic in nature, and that's how you are going to define aromaticity and anti-aromaticity here in the compounds, simple compounds like this. Yes, beta, yes. Okay, tell me. Is there any problem here? Is there any problem here? Yes. Now I'll see aromaticity in case of heterocyclic compounds where you have nitrogen or you have oxygen in between. So if you talk about in these compounds which will be involved in pi electrons, not involved, that we'll talk about. Here if you see this particular compound, this has 1, 2, 3, 4. Now firstly tell me one thing, in calculating hybridization, you will only involve those electrons that are not involved in delocalization. These lone pairs are involved in the delocalization, so I'll mark it here. These lone pairs are involved in delocalization, so while calculating hybridization, I will not involve it. These lone pairs will be in hybridization. In hybridization, only those electrons are involved that are not in not in hybridization, not in delocalization. In hybridization, only those electrons that are not in delocalization. Okay? So these electrons are not involved in delocalization, right? Okay? So that's why these electrons, and in case of pi electrons, you will involve those electrons that are in delocalization. These electrons are involved in delocalization, so I will calculate the pi electrons as 1, 2, 3, 4, 5, 6, 6 pi electrons. And these electrons are involved in delocalization, so I will call this is sigma, 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 so this will become sp2 because these lone pairs are not involved in hybridization. So that's why this will become aromatic in nature. What about this one here? right? Yes, everybody. Yes, Subhashree. Yes. So here what you will see, out of here the problem is that, ma'am, you have two lone pairs. Which one will be involved in hybridization, which one will be not? So here any of the lone pair will be involved in delocalization. So I'll mark this lone pair in pi electron. These will be involved in pi electrons, and this will be involved in hybridization, because this lone pair is not involved in the delocalization. So when you calculate the hybridization of oxygen, for oxygen it will be 2 sigma plus 1 lone pair, that is 3, that is sp2. So this is going to be sp2, all other are sp2. It is cyclic, it is complete conjugation. And while calculating pi electron, it will be 1, 2, 3, 4, 5, 6. It will be 6 pi electrons. So it will be aromatic in nature. Right, everybody? Is that clear? Is that clear to everyone or not? Right? Okay. But if I start taking offline classes, then how will I reach to more and more students who are there in different states, right? Sitting in the comfort zone of their home, right? Okay. So now if you see this one, tell me, will these lone pairs on the nitrogen, are they involved in delocalization or they are not involved? They are not involved. Now I think today's lecture is going to be big, right? Chalo koi na, we'll do that, right? These lone pairs are not involved in delocalization. They are only in hybridization. No pi electron. They are not involved in pi electron. So that's why pi electron will be 1, 2, 3, 4, 5, 6. 6 pi electron. This is again aromatic in nature. What about this one? These pi electrons, this is negative charge. This is the negative charge. So this is involved in delocalization. So 1, 2, 3, 4, 5, 6, 7, 8, 8 pi electrons, and that is anti-aromatic in nature. Okay? Yes, everybody understood? These are involved in delocalization, so they are pi electrons, right? That is very, very important for you to know. Then we have annulenes. In case of annulenes, they are monocyclic, alternate conjugated compounds. Only one cycle, and the number that we assign to that annulene will give you the number of pi electrons and the number of carbons. For example, if I say this one is 8 annulene, because 1, 2, 3, 4, 5, 6, 7, 8. This is 10 annulene. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's how you're going to tell that how number of carbon atoms are going to show you the annulenes, right? Now always remember non-planar annulene, this is from where the question is asked. Why 8 annulene is non-planar? Ma'am, it is cyclic, ma'am. It is, ma'am, sp2 hybridized, ma'am. It is, ma'am, planar also. It is cyclic also. It is complete conjugation also. Then why? Because it is actually not planar. All of them have sp2 hybridization if you see this, but actually it exists in a tub-like structure. That is why this 8 annulene is non-planar, so that's why they are non-aromatic. All these 3 annulenes are non-aromatic in nature because they are non-planar. Ma'am, why 10 annulene is non-planar? Because of this is hydrogen, this is hydrogen. These two hydrogen create so much repulsion that they go out of the plane. Instead of this, they go like this. Instead of this, they go like this. That's why it is non-planar structure, right? Then here also you will have hydrogen, hydrogen and hydrogen. In this case also repulsions are there. In case of 14 annulene, 18 annulene, the structure is even more big. That is why repulsions will not be there. So these 3 structures are non-aromatic, that you should remember. In case of 4, 6, 14, 16, 18, just they all follow PCC. Just calculate the number of pi electrons. For example, 4, 16, 4 to 8. 8 is not there, and then you have 16, right? Then 6 falls into aromatic, 14 will fall into aromatic, 18 will fall into aromatic. 4, 6, 14, 16, 18. Yes. So these, here you just have to calculate the number of pi electrons and that will tell you whether they are aromatic or anti-aromatic. Right, let's see one of the question here that says, assertion is annuline 6, annuline 8 and cis 10 annulene are respectively aromatic, not aromatic, aromatic. See, 8 and 10 annulene are non-aromatic in nature. So that is why first assertion will be false. Second is planarity is one of the requirement of aromatic systems. Yes, that is correct. So we will say A statement is not correct, R is correct. Why? Because this is aromatic, this is non-aromatic, this one is also non-aromatic. And this question they have asked you latest in 2022, a very simple question based on annulenes, right? Okay. Then the next question is, JEE means 2022, which of the following compound is not aromatic? You have to tell which one is not aromatic, not aromatic. The not aromatic means here you will have anti-aromatic as well, non-aromatic as well. Not aromatic means they should be not aromatic. Non-aromatic is different. Not aromatic means they are including anti-aromatic and non-aromatic, both of them here, right? So this is 1, 2, 3, 4, 5, 6 pi electrons, that is aromatic. Here you have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 annulene is non-aromatic in nature, right? Here, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4n plus 2. If you put here 2, then 4 to 8 plus 2, this will be aromatic in nature. Complete conjugation is there. This is 1 to 2 pi electrons are again aromatic. So, not aromatic is C. So, answer will be C is the correct answer here, right? Now guys, we are going to combine all of them, that is Barhi. Barhi means back bonding, right? You have back bonding here, right? Back bonding, then you have aromaticity. Firstly, we will see whether any of them is showing back bonding, then aromaticity, then we will see resonance, then we will see hyperconjugation, then in the last we will see inductive effect. Let me tell you how to answer these kind of questions. Before that, just remember one thing. Carbocation is like money, right? And carbanion is like stress, right? Whenever you have carbocation, if you are giving the electron, they will become stable because someone gives you money, you become happy. If someone takes out money from you, you will become very unstable, very unhappy. Similarly, this is carbanion. If someone gives you the money, if someone gives you stress, you will become unstable. If someone is taking away stress from you, you will become stable here, right? Okay, this is all you have to remember, right? So one by one, we will solve the questions regarding stability of intermediate here. First question regarding stability of intermediate is JEE 2025 question that is based on the correct order of stability of carbocation. This should be positive here. Now remember that whenever they ask you the stability of carbocation, always remember Barhi. Always remember Barhi. Is there any structure which is showing back bonding? Electron rich, electron deficient? I can't see any of it, right? So back bonding is not there. Any structure which is aromatic in nature. This one is aromatic, 1, 2, 3, 4, 5, 6 pi electrons, that is aromatic. So C is going to have maximum stability because it is aromatic in nature. Now rest of it we'll see if there is any resonance in any of the cases. Here you can see 3 times resonance because here, here and here, right? pH is nothing but phenyl. With carbocation it will show you resonance. Here you can see 2 resonances, So here 3 resonance means more stability A, then you will have B. Now last one, resonance we have seen, then we will see hyperconjugation, we don't even need to see that. Only this one is there, it has 5 alpha hydrogen, it will be in the last, that is D. So answer will be CABD is the correct answer. CABD, that is D is the correct answer here. Again, this question, correct order of stability 2024, and when this question was asked, this was asked in 2025. So every year you will see a question that is based on the stability of carbocation, stability of carbanion, acidity, basically these are very standard questions that we have. Thank you so much Lohaji, thank you. Sure, we will not stop that, don't worry about that, right? So you have this particular question here, correct order of stability of carbanion you have here. Now again guys, see, we'll focus on Barhi. Firstly, is there any back bonding anywhere? Back bonding, no. So I'll cross it. Is there any aromatic compound here? Yes, it can be there. This is 1, 2, 3, 4 pi electron. This is anti-aromatic, and anti-aromatic is least stable. This is 1, 2, 3, 4, 5, 6, and this is aromatic compound. So one thing I am sure that D is most stable and A is least stable, because anti-aromatic compound are least stable compound and no compound wants to be anti-aromatic in nature, right? Now talking about B and C, I'll focus on few things here, right? Firstly, though D is maximum, A is least, I can see only one answer here, so A is the correct answer here, right? But still I have to see this one is more stable or this one is more stable. So 5-membered ring is more stable as compared to 4-membered ring. So we can say C, then you will have B. So answer will be D, C, B, A is the correct answer here. A is the correct answer. Okay. Next question asked in JEE 2025 again, that is, in which pairs the first ion is more stable than the second ion? So you have to apply everywhere, you will have to apply Barhi again and again, right? In each of the cases, you will have to firstly see which one is more stable, which is less stable. Let's see that. In this case, you have resonance, lone pair, single bond. This is actually showing you back bonding. Electron rich, electron deficient. This is showing back bonding here. Here it is showing no back bonding. So back bonding is definitely more stable. Before back bonding, it gives you maximum stability. So this is going to be more stable. So this first is going to be more stable. In the case of B, you have here negative single bond, double bond. This is positive single bond, double bond, right? Here you have minus M effect. Here you have plus M effect. Plus M effect if you give here, right? Wait a minute, this is also minus M. Na? When you have a carbocation, you show minus M effect here, it is going to decrease the stability. Here you have minus M effect and this is carbanion. A carbanion is like a stress. Carbanion has stress. If you take out electron, it will become happy. So here, this will be more stable, right? Then in this case, this is resonance, there is no resonance. Because of resonance, this will be more stable. In this case, you have 3 methyl groups, and in this case, you have with resonance. If you compare resonance and in fact, see, if you talk about these two cases, back bonding is not there. Back bonding is there. See, back bonding is there. Because of back bonding, this will become more stable in any case, right? So you will say that in case of A and B, first ion is more stable as compared to second ion. So answer will be A is the correct answer here. Right everyone? That's how you're going to do these questions. Next question is that we'll talk about tomorrow. What are the important topics of structure of atom, right? Now JEE 2025 question, that is, which one of the following carbocation from the following is most stable? You have to tell the most stable carbocation, right? Again, this is based on stability of carbocations. So if you see this here, again we will apply the factor BARHI. In case of Barhi, what you will have? Yes, everybody, in case of Barhi, here you will have this resonance is there. Here you have this resonance, single bond, double bond. It is here also, it is here also, right? Here further you have, this will shift here, this extended resonance. Here this extended resonance is also shifted here, so it is cross conjugation. Here you also have extended resonance, this will shift here, this will shift here, right? But in this extended resonance, oxygen, see here you have cross resonance, this lone pair can also shift here, this lone pair can also shift here. So this is all eliminated from the most stable category. If you compare this one and this one, here you have fluorine which will give you extended conjugation, here you have oxygen. Oxygen is less electronegative, so it has more donation power. Moreover, here you have methyl group which will also show you plus side effect, so this is also ruled out. Now if you compare, this is CH2, this will firstly give you electrons. This is actually not giving you back bonding here. This is not giving you no extended resonance here. Extended resonance should be double bond and here it should be oxygen. So there is no extended resonance, so this is also ruled out. So answer will be C is the correct answer, because extended resonance you have, moreover plus I effect is there. So answer will be C is the correct answer here. Next is arrange the following carbocation in decreasing order of stability. Again, bacha, see these are like, I don't know how and how many times I have to tell you how important these questions are and how easy these questions are. You just have to know these concepts and I'll apply everywhere the same concept. Arrange the following carbocation in decreasing order of stability. This is oxygen, oxygen. Now if you see here, I can directly see oxygen has lone pair of electrons, right? Here it will show you back bonding. So back bonding is always going to be maximum stable. Here you will not directly have back bonding. This is no resonance will be there. This is lone pair, single bond, this. But here this oxygen will show you no resonance, right? See, back bonding is there in this case. What about this one and this one? What is the difference? Here aromaticity is not there in both the cases. Resonance is not there. Hyperconjugation is also same. This is alpha, this is alpha. Here also this is alpha, this is alpha. It also has 4 pi hydrogens. It also has 4 pi hydrogens. So hyperconjugated we can not define it. Based on inductive effect I can tell. Inductive effect is minus I effect this is showing. It will take out the electron making it unstable. Here you don't have any minus I effect. So it will be B, then A, then least will be C. So answer will be CAB is the correct answer. So answer will be, wait a minute. Acha, decreasing na? They are giving you increasing order or decreasing? Wait a minute. BAC, BAC, yes. This one is the correct answer here. So A is going to be the correct answer here. Next question is JEE 2023 question, that is again based on the same concept. Decreasing order of hydride affinity in the following carbocation. The one which is maximum stable, basically this is what they are asking you, right? Hydride affinity means H negative will be attracted to the most stable. Hydride affinity means hydride is going to attack where? Hydride is going to attack. This is a new way of asking the question. Same thing, they are asking you again stability of carbocation, but the question is hydride affinity. Now student will be like, ma'am, hydride affinity, what is that? See, H negative will be attracted to most stable carbocation. So actually they are asking you stability of carbocation only. So again you will apply Barhi here. And always remember, dancing resonance is even more stable as compared to back bonding. So in this case, can you see anywhere dancing resonance? Yes. This is dancing resonance, if you remember. Dancing resonance, dancing resonance. So 3 times dancing resonance, D is going to be most stable, dancing resonance is there. Back bonding, can you see anywhere? No. Aromaticity? No. Resonance, can you see? Here you have good resonance, good resonance, good resonance. So I can say after D you have B, right? Resonance is there. Now we will differentiate these two in terms of hyperconjugating effect. Acha, resonance you have here as well. This is resonance, this is more resonance, this is less resonance. So resonance, after this you will have A, which is showing you conjugation. Not a very big resonance, but some amount conjugation it is showing. Double bond, single bond, carbocation. Here last one will be C, and this is showing you 9 alpha hydrogen, right? Okay, but we don't have any more comparison, so we don't even need to calculate that. So answer will be DBAC. What they are asking, decreasing order means DBAC. Wait a minute. DBAC, wait a minute, decreasing order of hydride affinity. Hydride will be, oh, my mistake. I forgot one thing. Hydride affinity is inversely proportional to stability of carbocation. If the carbocation is very stable, then it will not be able to react. My bad. If the carbocation is stable, then it does not have the affinity to react. That is why H negative will not be able to react. So carbocation stability is this one. Then hydride affinity will be DBAC. So it will be CABD is the correct answer. So answer will be CABD, that is B is the correct answer here. Next question is the most stable carbocation from the following. Most stable carbocation, guys. Again BARHI. Now let me see how many more questions you have for this one. Not that many. Let us see. Not that many questions we have. We'll let this very few questions here. So now we have Barhi, right? See, I am trying to do as many questions as different possible. 2025 again, see in 2025 to 24 only I have taken so many questions, and these are not, I have not taken all the questions, right? So you can see the frequency of questions that they ask you from stability of intermediates. The most stable carbocation from the following is, firstly I will see if there any back bonding. No. Achha, here you need to do one thing. Whenever you see this effect here, this will shift here. Here you will have a carbocation. This will shift here. Here you will have a carbocation. That means this carbocation will be shifted here. This carbocation will be shifted here. This carbocation will be shifted here. This carbocation will be shifted. Also show resonance here, right? Okay. Now, if you see, this OMe is not going to give you any effect, but this one and this one is going to show you. This is going to show you back bonding. This is how you do these kind of questions, right? So directly to you will not see. Directly if I ask you, is there any back bonding? You will say, ma'am, no, there is no back bonding. But indirectly you will see there is back bonding, because when you draw the resonating structure, this positive charge will be on the para position. That is the reason it is going to show you back bonding here, and that is why this will be most stable here, right? That is why this will be most, this is a very important question that they have asked you in 2025, right? Okay. Then 2024 question, that is the correct arrangement of decreasing order of electrophilic substitution for the above compound. Now they are asking you electrophilic substitution. Electrophile, loves electron. So it wants to have a condition where maximum electron density is there in the benzene ring. So here you are giving electron with plus I effect. Here you are not giving electron. Here you are giving electron with plus M effect, right? And here you are taking out, because this F is showing minus I effect. So this is electron withdrawing group. So you are taking out the electron. So electrons are given in this case maximum. So this is 3 is maximum. 2, there is not giving, there is not taking. So it will be like, no. This is also giving, this is also giving. So then it will be first, because electron density is increasing. Here it is not increasing, this is not decreasing. Then in this case it is decreasing. Electron density is decreasing. So that's why this will be 4. So answer will be 3, 2, 3, 1, 2, 4. Correct order of decreasing order na 3, 1, 2, 4. 3, 1, 2, 4. So answer is B is the correct answer here. Okay, that's how you need to think. That's how you need to do the questions, right? In the exam, you should be pro in all these cases. Now, last two topics that are related to these electron displacement effect from where the questions are asked, right? That is acidity. That is also related to the same thing. Now, tell me what is the work of an acid. Acid wants to donate H positive and become A negative, that is carbanion. Acid will become A negative, that is carbanion, right? Acid has a work of donation, right? After donation, it will become carbanion. Now, this carbanion has to be stable. Only then we can say that this is a good acid. So, whenever they ask you acidity, you just have to check the stability of carbanion. And how carbanion are seen? When you give the electrons, they become unstable. When you take out the electrons, they become stable, because carbanion is like stress. When you give someone the stress, they become unhappy. When you take out the stress, they will become very, very happy, right? Let's see what kind of question they ask you. JEE 2021 question. Which among the following is strongest acid? You just have to take out proton from here. If you take out proton from this side, this will become positive. This will become, wait a minute, positive. This will become positive like this. This will become positive like this. Okay? Okay? And here when you take out the proton, you can take out it from here. This can be CH3, CH2, CH, CH3. Okay? Or it can be CH3, or it can be CH2 positive, CH2, CH2, CH3. Okay? Right? Right? Now, if you see this, if you talk about Barhi, acha, we are going to take the acid here, na? That means H positive we are going to take. So, we are going to form carbanion, not carbocation. That is the mistake that I was about to do here. This is going to form carbanion, not carbocation. Okay. So, this will be negative here. This will also be negative here. So, if you talk about Barhi, you have to see which carbocation is most stable. Is there any carbocation which is showing double bond, which is showing back bonding? No. Is there any carbocation which is aromatic in nature? This one is 6 pi electron, it is aromatic. This is 4 pi electron, this is anti-aromatic. This one is aromatic. So, the one which is aromatic is going to be maximum stable, most stable carbocation it will form, carbanion it will form. That is the reason it is going to be the strongest acid here. So, fourth will be the correct answer here. Next kind of question that they can ask you is the correct order of pKa. Now Ka and pKa are inversely proportional to each other. That depends, that is inversely proportional to the acidity. That is inversely proportional to the acidity. So if you have a good acid, right, then it will have less pK value. So firstly they are asking you correct order of increasing pK value. You just have to see which one is, this is negative, negative, this is a carbon ion, this is a carbon ion, this is a carbon ion. Carbon ion is more stable when you have electron withdrawing group. This has electron withdrawing group, this has donating, donating, this has withdrawing group. Electron withdrawing group at meta position, this is ortho and this is meta. Now always remember, at meta position minus M effect will not work. Here you will have only minus I effect. Here you will have minus M and minus I both the effect. So here maximum stable will be B, right? Maximum acidity will be B. Then this one is D, right? This is showing you, wait a minute, this is showing you minus I effect. This will show you, this is ortho and meta. Mesomeric effect is not shown at meta position. So this will only show you minus I. This will show you minus I and plus M. Where plus M is dominating, so this will be least. E will be least. Okay? B is maximum acidic, D is least. Here it is showing minus I. Here it is showing minus I. Here there is no effect. Out of this, which one has more minus I effect? Nitrogen or oxygen? Oxygen has more minus I effect, so that will be C, and then there will be D, and then there will be A, which is not showing any effect. So answer will be B, C, D, A, E. B, acha, opposite will be there na, for this is the value of Ka. pKa will be opposite, that is EADCB. 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 I think B is going to be the correct answer. Wait a minute. E is maximum, B is minimum, that we know, right? B, then C, then A, then D. A and D has the confusion. Answer will be, according to the options, the answer should be B, the correct answer, right? B is the correct answer, but I feel this should be the correct answer. Okay, let me see if I have done any mistake here or not. This is C, this is D, this is A. A is not showing you any effect. Here you have minus I effect, right? Here also you have minus I effect. This is also minus I. Here in this case you have oxygen, but there is also, acha, this is OCH3 na. This CH3 is also giving you plus. So it will be D, then C, then A. D, then C, then A. Wait a minute. D, then C, then A. D because it is minus I. This also has minus I, but it also has plus I effect of this one. Right? Okay. Here you have no effect, so it will be E, then you have A, then you have C, then you have D. But here they have given E, after then you have C, then you have A. Why C, then you have A? Chalo. Wait a minute, I am also getting confused here. This is, wait a minute, from here if this is the order, then this should be B, D, A, then C, then E. That means DAC they are saying, D is this one, then A, then C. So basically here they have considered plus I effect to be more, है ना? Okay, then things will change. Okay, how things will change here? Because as I am telling you that here you have minus I, that's why here you will have D out of C and A, right? This A is not showing you any effect, right? And this is showing you plus I effect from the CHE, so that's why here it is A. Then you have C here, and then the order will become E, C, A, D, B. Okay, then your E, C, A, D, B. Then this is going to be the correct answer. That means CH3 also you have to consider. Okay, my bad. CH3 also you have to consider. Plus I will be more as compared to no effect, right? Then guys, last part is basic strength. Here just remember that basic strength is directly proportional to availability of electrons. Availability of electron, that means electron donating group inversely proportional to electron withdrawing group. Now if you see this here, this is JEE 2024 question. Correct the basic strength of pyrrole, pyridine and p-pyridine. Now in this case, simple is you have to see these lone pairs which are maximum available, right? This lone pair is involved in delocalization, so this is not available. This is not involved, this is also not involved in delocalization. So this will have least basic strength. So pyrrole having the least basic strength, right? And then you will have, right? P-pyridine has maximum basic strength because these lone pairs are there, and also there is conjugation which is making this electron flow. So availability of electron is maximum here. In this, these electrons are available, but there is no conjugation because of which the electrons are flowing. So answer will be A is the correct answer here. Next and the last question of today is JEE 2022 question, which is which among the following is strongest Bronsted base, right? Now here also Bronsted base you have to see availability of electron is where maximum. Here you have 1, 2, 3 donation. Here you have 2 donation. Here these lone pairs are involved in delocalization, so this is definitely ruled out. Here also you have 3 donation. And always remember, when the donation is from a cyclic structure, that becomes the maximum donation, and that is why it is a maximum stable, that is maximum basic, that is D is maximum basic in nature because the availability of electron is maximum here. Right everybody? So that's it for today. We have completed, right? We have completed our class of GOC. Now on 5th of November, right, our Sigma crash course will be there for JEE 2026 aspirants, where we are going to teach you the high weightage topic in a short manner along with the questions practice. As you can see, in just 1.5 hours, we have done a lot of question practice, right? So similarly, tomorrow we are going to do structure of atom, which is again a very lengthy topic, and we are going to do a lot of question practice there as well. And it's a lengthy topic, but I'll complete all the important topics from there. Like you have Bohr's model, you have questions on quantum numbers, graphs, we have de Broglie hypothesis, Heisenberg principle. Then you have some questions from Millikan oil drop experiment, right? All these things we are going to, Rutherford experiment, everything we are going to talk about in the lecture itself, right? Okay? Yes, Chaitanya, I have just told you about it, right? Okay, so I'll see you all in the next class, that is tomorrow. Now at 3 p.m. you will have Namrata ma'am class for mathematics. So everybody do comment down what are your, like, are you feeling confident after these short sessions that we are taking? And we are completing a lot in this short sessions, the important things we are completing here, and with the proofs that how questions are being asked from these topics, right? Okay, then bye bye everybody. See you all tomorrow at 7 p.m. for structure of atom. Bye bye. And yes, I forgot to tell you one thing. One thing I forgot to tell you, that today is actually the last day, right, that has been extended to 2nd of November. So those who have registered, today is the last day for MVSAT scholarship program. All the best for all of you, and that's it.